let's walk through how this rational zero theorem works. What we're going to do here is we're going to take the following function. F of x is x cubed plus 2x squared minus 11x minus 12. And we're going to find all the possible rational zeros of that. What that is telling us is that we're going to figure out where do we start to find zeros. Where do we start to factor this? Right now you guys see it as 4 terms. And you would think, oh, maybe I can group it and get some GCFs. But if you just look at that, you probably can tell right away you're not going to get a GCF out there. So it's not going to be able to group. So what you wind up having to do is something that's going to sound very familiar. You're going to look at the tails of the problem. What I mean by this now is that I want you to look at the 12. The negative 12 here. What are all the factors of 12? So with it being a negative 12, it could be positive 1, negative 12, or negative 1, positive 12, right? And so on all the way through. So what we do is we write it as plus or minus 1, 2, 3, 4, 6, and 12. Those are all the possible factors of the constant. What's the leading term coefficient here? 1. What are all the factors of 1? 1. And you divide it by all the factors of the leading term coefficient. In this case, I'm writing everything as plus minus because we could have negatives, a negative times a positive, or a negative divided by a positive, something along those lines. Right there are all of the possible zeros of that function. You have, if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possible zeros of function. What do you do to start the problem to factor it then? You start with synthetic division. You pick any one of them to start with. Start with the easiest one, which is 1, 1, 1. So what happens here is you're going to use synthetic division. I'll come back to this. You'll use synthetic division to start with 1. Yes, sir?
Don't all numbers have a factor of 1 at the beginning?
They do, yeah.
What's the point of dividing it by?
Because it might be a 0. And we know if it's a 0 if this comes up as 0.
So we have to do that for all of them
Well, here's the thing. Remember,
until you find 3.
No
Remember.
wonder.
2.
no whining.
No, that's a question.
It is a question. And I haven't even started the problem yet.
Oh.
So,
No pre.
back the truck up, sister.
Whoa.
That was good, wasn't it?
Yeah.
All right.
Factor up.
Well, it was funny. Breathe. Everybody's staring at her. She's turning red. It's funny. The top of your head is red now. You got like sunburn.
She's the only one that thought it.
Do you feel the heat coming off? Don't put any paper on it. It might actually light on fire.
The shame.
Yes, they're all looking at you. Where's the cone of shame?
Oh, there.
Oh, yeah, there it is. Let's get it.
Yeah.
Why do you make the face big?
Oh, she's crying.
That doesn't look like a function.
Function. Hope you're busy.
I know she can put it
All right.
Oh, she's crying.
Put it in your phone.
Yeah, oh. Yeah, don't drop it.
Okay. I'm sorry.
I
gotta smack it.
Anyway. So what we're doing here is we're going to use our list of possible zeros to find one. And remember, synthetic division is very easy. 1, 1, 3. Thank you. 1, 1, 3, 3, -9, and it doesn't work. If it doesn't work, what do I do?
Just.
Change it.
Oh, to -1. Wait.
Did I do that wrong? Hold on. 1, 1, 3, 3, -8. Yeah, it still doesn't work, so. Okay. So I erase it and I go to -1.
Yay.
1, -1, 1, -1, -12.
Uh-oh.
12.
Uh-oh.
0. So in this case, I only had to do it twice, and I found one of my first zeros. Now remember, when you find a 0, what happens to the degree of what you're left with?
It becomes minus 1.
Yeah, so this case, now your term, your 0 is -1. So what is your term then in parentheses?
X plus 1.
So it's x plus 1, and now I'm left with x squared plus x minus 12. And I'm trying to find all the rest of my zeros, and now am I at a point where I can factor something easily?
Yes.
I can factor that, right?
Yeah.
What's -12 to get you a positive 1?
4 negative.
So you have x plus 1, x plus 4, and x minus 3. Your 3 zeros then are at -1, -4, and positive 3. It is. Using synthetic division with rational zeros, it allows you to factor extremely fast. It's a very efficient, quick way of doing things, okay? Once you get over the initial, oh my god, are there more than once? It's pretty
I
easy.
think what we were afraid of was doing all of the numbers.
You don't have to. I mean, to be honest with you, then you might have to do 4 of them before you find one of them. It happens.
What if there's no constant, and like, what if it's just this?
Then you have a GCF. And then you can take out the GCF and you have it a 0 at 0, and then you can take it to the other, what was left over, and then go from there. That's a great question. Here's what Lydia was asking. What happens if it's something like this? What happens if it's something like that? What would you do first when you're trying to factor that? Take out the x, and then you have your x cubed plus x squared plus x plus 2, and then you can go through something like that. This is kind of a bad example because I don't think it'll actually work, but it's the same idea. Does that make sense, though?
Yeah, wait, does you factor the 2 or the x?
I would use the 2. That's a great question, okay? So let me look at this again. Remember, what we're doing here is I want to look at listing out my possible zeros. When I want to list out my possible zeros, all I'm doing is I'm listing all of the factors of the constant, plus minus, divided by all the possible factors of the leading term coefficient. It just so happens that in this example, again, the coefficient is 1. So we just go through the 56. Remember, it's going to be plus minus 1. Does 2 work?
Yes, yes.
Does 3 work?
No.
No. Does 4 work?
Yes.
Good. Then what?
7.
8. 56.
Okay. And what do you have to divide these all by?
By 1.
By 1. Okay, you can write by plus, divided by plus minus 1. Now, is it kind of redundant to write it over plus minus 1? It is, because eventually that leading term coefficient isn't going to be 1. I'm just getting you in the habit of it. Okay. So all you'd have to do then is just go through your listing again. Yes, ma'am?
Why is the bottom plus or minus? Like, I get why the top is plus or minus.
Well, what's positive 1 times positive 1? What's negative 1 times negative 1?
If I don't,
Because you have you can still change your signs that way. Now, what's happening is that you could have a positive 1 divided by positive 1, positive 1 divided by negative 1, all the way through. It's just changing that your denominator should be plus minus as well. That's all. Because remember, whenever you take two numbers, if let's say your leading term was 2. There's a positive 2. The factors would have been 1 and 2, would you agree? It could be 1 times 2, or negative 1 times negative 2. That's what I'm
So
getting.
you're just doing the factors of the first one, it's not just the coefficient.
Yes, I'm doing I'm doing the factors of the coefficient. The factors just of the coefficient happens to be 1,
Okay.
and that's all it is. Okay.
Can I get rid of that before you use yourself?
Of course. All right. That's how you list them. Now, the weird list comes into play if you don't have a coefficient of 1. Let me show you that. Okay. I want to look at number 6 here, and I'm just going to list them. remember, what we're looking at are listing out the possible rationals. It doesn't always mean that they're always going to work. You could have an irrational zero, you know, something with quadratics, things like that. It could be an imaginary root. We haven't gotten to that yet. Now, if I want to list these out, I have f of x is 2x cubed plus 7x squared minus 7x plus 30. So I list out all of the factors of and divide them by all the factors of 2. Very good. I was just listing them. I wasn't trying to, I'm not, I know that some of these don't work clean, so I'm just listing them right now.
I was just wondering.
That's all. Yeah, I know the first one works cleanly. These last two don't work real clean because you will wind up with irrational zeros, and I don't want to confuse you with that yet. I just want to get you the habit of listing them out. When I go into actually solving them, they're going to work.
We're going to go back and solve the problem and just restart it. You're going to go back and restart it.
So we're going to continue there. So you have plus or minus 1, 2, 3, 5, 6,
10,
everybody okay with that? Yes, sir. Now, when I look at these, I have all of this written out like that, but it really means that I also have a set of fractions of 1/2, 2 over 2, 3 over 2, 5 over 2, 6 over 2, 10 over 2, 15 over 2, and 30 over 2. That's what it happens when you divide everything by 2. Do you agree?
Yeah.
Are there duplicates then?
Yes.
Where?
2 over 30.
2 over 2, 6 over 2.
10 over 2.
What's going to happen sometimes when your leading term coefficient is not 1, you will wind up with duplicate possible zeros. That's all. It's just showing that you could have a 0 at 1/2. If your 0 is 1/2, what would your term be?
Oh, it would be like
2x minus 1. Very good. Everybody hear that?
Yeah.
If my 0 equaled 1/2, that meant my term would be 2x minus 1. That's all that's saying. That's what that means when you have a fractional 0. Does that make sense?
Would it be wrong to write x minus 1/2?
More often than not, it would be a leading term coefficient where you have a 2x minus 1, something along those lines. It's not necessarily not right, but usually what's going to happen when you have terms, it usually looks like that. Okay. I don't think it really does something you just said. Good stuff. All right. So again, not very tricky, is it? Okay. So let's do let's find all the zeros. What I mean by this, by finding all the zeros, we're going to factor this completely out. We're going to use synthetic division to do it. So we have f of x is 2x cubed minus 5x squared minus 14x plus 8. First thing you need to do is list out all your possible zeros, which means you're going to worry about all the factors of divided by all the factors of. Very good. When I'm looking at this with the fractional amounts, what's the only fraction I'm going to have to worry about? The plus minus 1/2. Do you guys agree on that? Do I need to write that down, or are you okay just leaving it like this? Just remember that's what you're looking at, okay? Where do you start? 1. You can start at 1/2 if you want. Doesn't matter. And what's your goal when you're synthetically dividing? What are you trying to find? A 0 where? At the end. So, synthetically divide. Not going to work. You're going to be able to tell rather quickly as you're synthetically dividing, hopefully as you go through these a few times, you probably don't need to complete the problem. So once you realize it's not going to work, you erase it and you start over. Now here's the other thing that happens. Let's say you synthetically divided incorrectly and you erased one that was going to work. Are you eventually going to find another one anyway? Yeah, you should, unless you're really screwed up. Okay? So you go again.
So you suggest the pencil for the homework tonight, no?
I'm sorry, what was that?
So would you suggest the pencil for the homework tonight?
Absolutely, yeah. A pencil, you probably don't want to. You probably don't want to do this one in pen.
What do you mean?
So close, but yet so far.
Because no. Well, 7. So it's not even.
I'm hungry.
Oh, wait, try half. I'm feeling -2 right now.
Oh!
Go.
Oh no! You had to do synthetic division 4 times with 1s and 2s. Oh my lord! I'm melting.
Go pour water.
All right.
Put it on my
Put on the hat.
And that's gonna break.
So when I do this, I really yes.
You can't get a fat wine or so fall.
Now I know that -2 is a 0, right?
Yeah.
What's its term?
X plus X.
Good. So we have a term now at x plus 2. I'm going to leave this off to the side. Because now I'm left with 2x squared minus 9x plus 4. Could you try to factor that if you want?
Yeah.
Okay. Could you try to factor that, or could you continue on using synthetic if you like?
Well, yeah.
You can do either way. Colin, you look like you don't believe me.
I'm believing you on.
All right. 2 times 4 is what, Colin?
8.
What times what's positive 8, but you add it together, you get -9.
Nothing.
-8, -1.
Negative 8, -1. So you can split this as a middle term, go 2x squared minus 8x minus 1x plus 4. Factor via grouping, 2x, x minus 4, -1, x minus 4, and you wind up with 2x minus 1, x minus 4,
Oh my goodness.
to go along with that.
So you do get a half.
In this case, you do. Now, if you were just being, let's use a half, man, let's use a half. And I was up here, move this over a bit. I love the smart board. Now, if you wanted to go ahead and say, I'm going to use synthetic division at this point and use 1/2, go for it. Well, drop the 2. What's half of 2? -9 and 1 is? What's half of -8? So 1/2 was a 0. 1/2 is a 0 then.
Wow.
What are you left with? 2x minus 8 equals 0. What's the other 0? 4.
Whoa. That is crazy.
You can do the same thing. We'll do more of the continuation of synthetically dividing tomorrow. But I'm saying you can do that.
How did you know?
Ali was just being Ali. He said, let's try a half. Now, remember, we know that -2, 1/2, and I think 4 were all of our 3 zeros for this that actually worked. If you just randomly selected, I'm going to start with 4, you would have found that 4 was a 0 and you would have had a different trinomial factor. You could randomly guess and try. I say go sequential, start at the bottom, work your way through. Okay?
Turns out.
At worst, you might have to do synthetic division 4 times, 5 times.
10, 11.
All right. Not that scary, is it?
No.
Okay. Because it makes everything so much easier when it gets to this. Notice my degree now.
It's a 5.
It's back. I'm going up to a 5th degree polynomial.
So that means we're gonna have positives.
You can have up to 5 zeros. Now, a 5th degree polynomial can have up to 5 possible zeros. Remember, it can have up to 4 possible changes in direction. What do the tails look like on this problem as far as the graph is concerned? We know we're going up and right, kind of like your slope is positive, okay? So I know that there are these little things that are happening. And if I'm going to find all of my zeros this way, I do the same thing. I list out my possibles on the tail. So what are the possibles of 6?
1, 2, 3, 6.
1, 2, 3, and 6. My coefficient is 1. So I'm looking at all the possible zeros now of plus or minus 1, 2, 3, and 6, divided by plus or minus 1. I'm going to synthetically divide now, starting with 1. I'm doing the same exact process. Pull your coefficients. Do I have to be careful about this one now? Why? Gotta add a 0, gotta get a placeholder. Good. So we have a 1, negative 2, 0, 8, negative 13, and 6. We're going to search for a 0. 1, 1, negative 1, negative 1, negative 1, negative 1, 7, 7, negative 6, and 0. Yay!
Question about that, that's good.
We got lucky. And sometimes you get lucky in the first try. You've now dropped your polynomial 1 degree, and you found your first 0. You okay with that? All right. You know you have a 0 at 1, therefore you have a term at
X minus.
x minus 1. Yes, sir.
Because, so you can have up to 5 zeros, so that means all those numbers can be zeros?
It's possible. But I also want you to think about this, and this is where we get to a little bit more of the messiness tomorrow. When you have a graph, and just thinking in terms of a quadratic can touch the graph twice, right? It can touch it once, and it can touch it once.
New word.
New words. Okay. What does this look like if it touches it at one spot? What is the term? What is it? Smiley face? It has 1 0. Let's say the 0 here is at negative 3. If the 0 is here at negative 3, what's its term?
X plus 3.
Very good. Doesn't that a 0 occur twice at the same spot? Remember, sometimes when you have quadratics, you could have x squared plus 6x plus 9. You could have a perfect square. Perfect squares could be hidden within upper degree polynomials, and that could happen. It's not going to happen so much tonight, but tomorrow you're going to want to start over at 1 again, okay, and build up. Okay, so if I went back to this one, I wouldn't skip and go to negative 1. I would try 1 again just to see if it's not duplicated, because that's what could happen. You could have a graph that, oops, I went the wrong way. You could have a graph that is doing, it's going up, your tails are going this way. It has 1 change, 2 change, 3 change, 4, oh wow. But whatever, it could look like that, where you're coming across and you're touching it at one spot. It's a bad diagram, but that could occur, where it's a duplicated 0. Does that make sense? Not as much today, but tomorrow what I want you to remember, start over at 1 again. 0, 1, 1, 0, 0, negative 1. And all of a sudden, that's duplicate.
Again,
triple.
It wouldn't, it should not, I don't believe it shows up tonight, but it's just a little it's just like a little precursor of what you guys like to think of as the worst case scenario, and I don't know why I like to use air quotes, but it's kind of fun.
It doesn't work.
So it's not
triple.
fun.
It's not triple.
Is there such thing as?
Yeah, I don't know.
Could, I guess.
Wait, how do you know if it's duplicated or not?
What is the?
You won't. It's just try.
All the zeros at the
It's
top.
just a little bit try. Remember, this is something, the process that we're using here, by using the synthetic division, it's easy just to try them again, and it doesn't take that much time. Okay? Leave it at that? All right. We'll finish this one out tomorrow.
Okay.
So tonight's work is just in section 6.6.
You're not gonna give us any fifth degree politics.
Not tonight.
Same here.
Let's say you didn't finish this problem.
No, I know. I just wanted, this is what I've done throughout the day today, is just kind of show you guys where we're going.
You're welcome. It's all me.
I want to say it's 362. I don't remember.
It is going to be
63. Okay. I want you to do 40 through 52.
again.
363, 40 through 52 evens. Okay.
Again.
Yeah, it's basically the same problem. It's not the same problems, it's just the same numbers. Right? A lot of the other, no, I don't want you don't need to do the ones in here, again, you're going to be finding all your possible zeros. There's no reason for us to do the problems that says, list out all the zeros. Is this a zero? What's the point? You might as well get right to the point of doing the work that you need to get done, right? They said like tomorrow we'll finish out where we left off in that 6-7, and then we're gonna work backwards.
Oh, great.
I was thinking about that.
Love it.
If I give you a zero, yeah. If I give you a zero, what's your turn?
I don't know. We're gonna learn tomorrow.
Let me ask you this. If your zeros are at -3, 2, and 5, what are your terms? Then what's your polynomial?
Something crazy.
Third degree?
X cubed something, right? Could you multiply all that out to write the polynomial?
Sure.
Could you also tell me what the graph of this looks like?
Yes.
Knowing that you have zeros at -3
You got it. Next, no.
At 2. and 5, is this, it's going the other way because you have a negative in here. You know it's going to look like that, right?
Why did it?
Why did that seem a lot easier?
Oh, wait.
Because I've been beating you guys over the head with zeros and terms all throughout.
No, I'm talking about just the zeros. I was thinking it would be a positive or a negative.
Oh no, this one should be positive. I'm sorry.
Nice job. Nailed it. Don't even got to try. Don't even got to try.
You got it. It'll be positive. Yeah, it is positive because it's. I was thinking of the negative multiplier. All right. Go give those a shot. You should be all right.